Okay, next we are dealing with enzyme inhibition. Okay, there are in enzyme activation there are many steps. Okay, so enzyme itself is regulating a lot of functioning, isn't it? Enzyme is acting as activators, enzyme is acting as inhibitors, isn't it? We have learned allosteric modulations where you can see here positive modulators and negative modulators. So thereby you can regulate an enzyme reaction. That we have learned in allosteric modification. We have learned what is allosterism. Other than active site, there is another site where the substrates can come and bind. So there is a positive cooperativity and negative cooperativity that has been activating during this enzymatic reaction. Okay, so our ultimate aim is for enzyme substrate complex formation, and because of this inhibition activity, there can be variation in Km value and also Kv max value, isn't it? So for promoting this enzyme substrate complex formation, it should increase the Km value and decrease the Km value and increase the Vmax value. Then only the enzyme reactions can activate very fastly and conversion take place. Okay, so when an inhibitor come and bind, there is a conformational changes that is happening in the active site. So this can cause the enzyme substrate complex formation to stop. Okay, so during that stoppage, what happens is that there will be an increase in Km value and decrease in Vmax value. By Vmax means what? Enzyme substrates are being formed, enzymes are existing as individuals, enzyme product formation is also seen. So if there is an enzyme substrate complex inhibition, the Vmax can decrease. So Vmax decreases means what? The Km value can increase. So this an allosteric inhibition is happening, and there are many enzymes. The rate limiting steps we have learned in enzyme substrate complex formation. E plus S give ES. Then ES is converted to EP. So all these are regulatory steps. Covalent modifications are also acting as a regulatory steps, because this covalent interaction is very essential for the binding of binding of these molecules, isn't it? Enzyme substrate complex formation. If there is no any proper for the removal of chemical groups or for the cleavage of this enzyme molecule, all we require covalent bond. So covalent for phosphorylation take place, dephosphorylation take place, then adenylation take place. So all these are common covalent modifications, and deletion of some modifications can cause activation or inactivation of enzyme formation. So for example, if you talk about glycogen synthetase, that is active, and glycogen phosphorylase is inactive, because the phosphate group is added to that, it causes the inactivation of that particular function. So covalent modification is also a regulation. Okay, regulation I'm talking, allosteric and covalent modification are regulation. Now we are talking about types of inhibition. So inhibition, we can say that there is a reversible inhibition and irreversible inhibition, isn't it? There is a reversible inhibition and it can be changed. Okay, such a kind of reactions can be changed, but there are some changes that never happen, just like protein denaturation. It cannot be reversed back, so that is irreversible. So there are enzymes because of poison or antibiotics or insecticides. All these can cause inhibitions, and there will be no any reversal also. So both enzymes can act thereby inhibit the substrate by reversal or non-reversal method. Okay, so there are different kinds of inhibitions that is you have to learn is in reversible type. In reversible type only we are just moving with, that is first is competitive, uncompetitive and non-competitive. This is given in your textbook, and there are other type of inhibitions also, but basically competitive, uncompetitive and non-competitive is the basic thing. There are substrate linked inhibition also, product linked inhibition also, then end product also is been inhibiting the function of enzyme substrate complex form. So first we will look through these three of them, that is this one, competitive, uncompetitive and non-competitive. So all these are reversible type of inhibition. Okay, this has been asked what are the different types of inhibition that has been seen in enzyme action. Okay, so first is competitive inhibition. What is competitive inhibition? The inhibitor is almost similar to substrate. Okay, the inhibition is almost similar to structurally homologue of substrate. It can prevent ES formation. ES means what? Enzyme substrate complex formation is prevented. Because why? The inhibitor is acting on it. So you look this one. You have an enzyme, you have a substrate, and enzyme substrate complex is formed and EP is also formed. But if there is a competitive inhibitor, what it is doing is that onto that enzyme active site, you can see somebody else is coming and binding. A competitive inhibitor is coming and binding. So this inhibitor is coming and binding, and it will not allow the formation of ES. What is ES? Enzyme substrate is not at all formed. So this prevent the binding of the substrate to its specific site. So this can block the reaction. Okay, so it can prevent ES complex formation. So this both compete with substrate for same active site. See, look at this diagram. These two fellows, that is our substrate and also the non-competitive inhibitor, both are competing for this active site. So who is the one winning? That inhibitor will come and sit onto that active site, and thereby EI is formed. What is EI? Enzyme inhibitor complex is formed. So this is enzyme inhibitor complex. So there is no any product formed. So that is the condition over here. Okay, there is no any product that has been formed. So this can inhibit, the enzyme can inhibit the formation of ES formation. So this kind of inhibition is also called as isosteric inhibition, because the substrate is almost, or inhibitor is almost similar to substrate. Their shape is almost similar to substrate. So it is isosteric inhibition. So this is a competitive inhibition. So in competitive inhibition, you can see that the Vmax is same. See, Vmax is same, but Km is different. Okay, Km varies. Vmax is same. This red one, no? Vmax is reaching in same direction, but the the Km value will be different. Okay, this is in the condition of what? Competitive. Competition for entering into the active site. What about non-competitive? No much participation, no much correlation is happening here. The inhibitor prevents the catalytic conversion of substrate. It will prevent the product formation. It prevents product formation. Okay, it prevents product formation. It will block the ES formation. Enzyme substrate complex formation has been blocked. Okay, but it interfere with the. It's never been blocked. Sorry, it is never been blocked. Enzyme substrate complex formation take place. But what happened? Never allow this enzyme substrate to form EP. What is EP? Enzyme product complex formation. Okay, ES is formed. See, ES is formed. But what happened? ES is formed. But no, what happened? No enzyme product is formed. No enzyme product is formed in this reaction. Okay. So this kind of, the turnover number means what? The affinity, the formation of complex, it reduces the complex formation. In this, it doesn't affect Km value, but it decreases the velocity. It reduces the product formation. So if there is no product is formed, so it can decrease the velocity, but Km value will always does not affect. So this is the diagram showing what the Km value is same, but look at the velocity. Velocity comes down. Okay, and the Km value is same. That means Km value means what? The formation of Vmax value, half Vmax value. The formation of enzyme substrate is forming there, and but enzyme product formation has been restricted. Okay, that reduces the enzyme formation, product formation by decreasing the velocity. So you can see that enzyme in non-competitive inhibition, it can either bind to the active site or the catalytic site, or outside the catalytic site. Look at this. It can. This is the what? This is our enzyme. This is our substrate, and this is our inhibitor. So the inhibitor is not going to the active site. It is moving to some other place, some allosteric site. Okay. So what will be the thing? This product formation it won't allow. Okay, this inhibitor when come and bind to the catalytic site or other than the active site. This is the active site. Okay, this is the active site. Other than the active site, this inhibitor is binding. So what happens? There is no any EP formation. EP formation means what? The enzyme product formation is not happening. The velocity is decreased. Km value will be almost there will be no change. So the rate of reaction is always proportional to concentration of I, because I is the one playing an important role here. It can allow the formation of ES but doesn't allow the formation of EP. Okay, so the rate of reaction directly depends upon both enzyme and inhibitor. So it is not fully reversible. Okay, this is not at all. We have already done inhibition action as reversible. Okay, this one reversible, uncompetitive, but or non-competitive, but it is little, not that much reversible. Okay, so next we are moving to uncompetitive. So first we finish competitive, then non-competitive, and the next one is uncompetitive. So what is this? Inhibitor will help the ES formation tightly. So inhibitor will facilitate ES form, enzyme substrate complex formation very tightly. Okay, it can bind to the substrate part, substrate where the substrate go and sit, there it can bind, and inhibitor can inhibit enzyme reaction. Enzyme reaction can be inhibited because the I is binding onto the substrate binding area. It can be active site, right? So this depends upon the affinity of inhibitor of the substrate. So here inhibitor is having a very good role. It depends upon the inhibitor to sit on the substrate. Look at this diagram. See, this is the last one. This is the substrate. This is the inhibitor. See, look at inhibitor is sitting on to the substrate. Inhibitor is sitting on to the substrate. Here what you have seen, an inhibitor is moving into not the active site. It is choosing another place. Okay, so in uncompetitive you can see that the inhibitor is always preferring affinity to the substrate area. So it is always more binding to the substrate part. So inhibitor has more affinity for substrate. For this one we have an example there. Formation of inhibition of placental alkaline phosphatase by phenylalanine. Phenylalanine amino acid, when we add, it causes the inhibition of alkaline phosphatase enzyme formation. Okay, so uncompetitive, you should understand that the inhibitor is always binding to the substrate part. It is always having affinity for substrate. Substrate active site, it has been acting and it will inhibit the ES complex formation. Here what happened? Non-competitive, the inhibitor is choosing other than active site, some other site outside the active site they are choosing, and it will block EP formation. But what about competitive? The competitive, the inhibitor is always choosing the active site, always binding with the active site. It will not allow the formation of here you can see that it never allow the formation of ES. Okay, ES is not at all formed because a non-competitive inhibitor is playing an important role over here. So today's class we have learned different types of inhibition, that is competitive inhibition, non-competitive inhibition and uncompetitive inhibition, and the role of Km value and Vmax value and how it has been affected. Okay, this graph clearly explains the competitive inhibition and non-competitive inhibition. Okay, and in uncompetitive you can see both Km and Vmax value decreases because there is no any product formation or enzyme substrate complex formation. So this is the understanding of inhibitions in enzymes. Okay.